today's session, well, this afternoon's session is an iPhone I for the .NET guy. Basically, we're a whole bunch of .NET programmers. How on earth do we write apps for the iPhone? Why do we want to? Why do we care? How can we leverage our existing skills in order to produce an app without having to go and relearn our entire trade from the get-go? So there is lots of stuff on the menu. We'll go through a quick intro, basically, hello world, this is how it all works. This is, these are the bits, these are the components. So what's this whole MonoTouch thing? How does it play with MonoDevelop? Some simple stuff. We'll play with a little bit of cool stuff here and there. So things like some fairly basic table lists, incremental search if we get a chance. We are running a little bit behind time, so I'm going to cut material as we go. I'll be guided by you guys as to which bits I cut. Right. We're going to have a look at some slightly more advanced bits and pieces, so threading, generics, reflection, inversion of control. Throughout the afternoon session, some of these will appear. If this ever figures itself out, it'll actually take a question page from the live DDD Brisbane hashtag. So if you've got feedback or anything else, by all means tweet it. I'd rather that you told it to me, especially if it's bad, because we can skip the bad bits. But also, if you interact with me, you run the risk of being given a lolly. Introductory stuff. Why would we actually choose to develop on iOS? What's in it for us? Why is it any good? Conversely, there are lots of reasons to not choose iOS to develop on. There are lots of really nasty things about it as well. And what are our other options? If we want to build a mobile app, as opposed to we actually want to build an iPhone app, what are our other options? Now, anybody who's been around for the rest of today will have seen a whole bunch of ones around web, PhoneGap, all those sorts of things, so I'm not going to rehash those. But it's worth knowing that just because you're writing for the iPhone doesn't mean you have to actually write for iOS. So, why iPhone? Because it's a beautiful piece of hardware. Okay? It really is. It's a nice piece of hardware and people want it. Okay? It pre-sold over 1 million in pretty much every single country that it's available in, right, which is just insane. People want this platform. What that means is that people want to be able to be your customers with the App Store. The App Store is a walled garden. We're not going to make any bones about that, and I'm certainly not an Apple apologist. I'm not wearing a black turtleneck. I was thinking about it, but then they gave me a free t-shirt. So, all right. So, the App Store, yes, it's a walled garden. Yes, Apple may just decide, you know what, it's Tuesday, piss off, we're not accepting your app. Okay, and that's fine. Right? That's just a risk we take. But the flip side is that it's amazingly easy for people to spend money with you. Right? Apple takes their 30% cut, so what? Right? I'm making sales because someone is selling my app for me, someone's promoting my app for me if it gets in the featured lists and gets popular enough. Someone's effectively going to just market my app for me. Awesome, I'll take that. So thanks very much. Who likes Windows Update? Who likes Windows Update? Anyone? Wow, not one person. Okay. All right, well, you were going to get a lolly for being the first sad person to put your hand up, but since nobody did, no lolly. I will remind you that they're here. Okay, all right. So the platform is stable with iOS, all right? It's well maintained, it's well updated. When Apple releases a new version of iOS, iTunes will upgrade your mum and your grandmother's iPhone for them, right? You don't have to worry about upgrading your platform. You don't have to worry about will my telco allow Mango, right? Which is a shame because Mango is awesome, but Telstra has to let you have it. Right? Apple says, here's the new iOS. Everyone says, thanks, I'll have that. Right? Done. Very, very happy. It's easy to code for. Right? I'm not going to go into the fragmentation of Android. We all know that it's a bad design decision to allow telcos to brand the universe and ship their own crapware on everybody's phone. We also know that pretty much anyone who buys Android wants to go and root the thing anyway and reskin it with their custom skin or their custom OS. So we're not going to go there, except to say that Android's got market share, but it's horrible. Windows Phone is awesome, but doesn't have market share. If you want a really nice development environment, Windows Phone is it. Right? You get the Visual Studio debugger, you get all sorts of awesome toys, you're playing in Silverlight, it's a known technology. You're on your home turf. Sorry? You just don't have customers. Yeah, precisely. You just got bugger all market share. So you can have the bestest app that nobody ever buys, which is a real shame. Again, the iPhone is a beautiful piece of hardware and everyone wants one. Do I need to go through these again? All right. The last one, in terms of why you do want to develop for iOS, is that it's easy for a one-man band I'm sorry to how many females in the room? One? Okay. It's easy for a one-man band to make a profit by themselves. Okay? You can write an app and you can sell it. And if it's successful, it doesn't matter that you're small. Okay? It's easy. The barriers to entry are low. The bad. The platform's freaking horrible. I'm being recorded here, so I can't say exactly what I think of it, but the platform itself is not your friend. I'm consistently astounded by how many beautiful, beautiful applications come out of such a horrible platform. It's a nasty development experience. It's really not your friend. Okay. We've been through the app approval process. We know this, all right? Yeah, you can have it. No, you can't. Actually, we said that you were approved last week, but now we've pulled it. You know, it's completely arbitrary and up to Apple. Did anyone see Google Voice get accepted to the App Store? Yeah? How long did that take? 2.5 years? Something like that? It was being evaluated for 2.5 years. Yeah, that's the sort of territory you're playing with. It's Apple's sandpit, and you'll play in it on their sufferance. Right? You're not allowed to use a whole bunch of stuff that the native Apple apps use. Things like, what's my phone number? No, bad. What's my device ID? Until recently, okay. Now, no, bad. We'll reject your app for that. Okay. And they do. They just programmatically check which API calls are you calling. Are they on the allowed list? No, get out. Actually, no, stall for about a week, then get out. Okay. And your resubmit lag is pretty painful as well. Basically, they don't want people just going, oh, I fixed that one and chucking it back over the wall again. You guys test it for me. Right? They will actually enforce a lag. They will enforce a turnaround time so that you actually care about having a decent product that goes into the App Store. Now, like it or not, this is working because by and large, apps in the Apple App Store are decent and apps in the Android App Store are... Let's skip that bit. All right. Now, obviously, if you're deploying to the enterprise, then you don't have to go through the Apple App Store, so the API constraints don't count. The easiest way to deploy apps to your enterprise iPhones is by plugging them into iTunes, dragging things onto them, giving it back to the person, and then plugging in another one. Lather, rinse, repeat for 40,000 employees, and that's going to go down real well. All right. You can actually deploy enterprise apps over the air. If you have a 40,000 app or 40,000 seat contract, by all means, you're going to be able to afford to deploy apps over the air. But if you're talking small in-house apps for small divisions or small companies, then they're going to have to plug it into iTunes. Some good, some bad. Mileage may vary. Right. The last thing is iOS itself is not at all friendly to managed code. No JIT. No JIT whatsoever. If you have to dynamically compile code on the platform itself, you're gone. Right? iOS will just shut your app down, tear it out of memory. Sorry, you can't go there. Right. So what are our other options? Well, we've looked at most of them. We've looked at Windows Phone. Again, awesome dev environment or full market share. Android, excellent market share. By volume, Android's selling more than any other mobile operating system on the planet. But no one wants to code for it because it's awful. Right? No one wants to code for it because actually getting your app distinguished in the Android app marketplace is incredibly painful because there's just so much dross. So we don't want to go there. The other option, of course, is web. Now, I'm going to go out on a limb here and say I don't like JavaScript. That is changing. I used to utterly despise JavaScript. Now I just dislike JavaScript. The tooling is one hell of a lot better than it used to be. Okay? But that having been said, I really like the idea of being able to make a typo in a variable name and have a really cool convention-based test harness, i.e. a compiler, tell me. Whereas in most of your JavaScript, well, you don't get that. You make a typo in a variable name and it just magically creates one in the global scope. What's more? All right. Little things like that. So web is really, really portable. It's awesome. If you saw Brendan's drag-drop web app into PhoneGap not so long ago, hit compile, run, awesome, and everyone applauded, that's great. But the downside is you have to code in JavaScript. Okay. Your mileage may vary. It's not my cup of tea. So UI stuff, how are we? Yeah, we are going to have to move. All right, UI stuff, touchy-feely stuff. We'll skip over most of this because we're not touchy-feely people, right? Except to say that your UI paradigm has to change between mobile and desktop. You have to think differently. You cannot make the user wait. You just can't make them wait, right? Make it easy, make it intuitive, do everything that you need to asynchronously. The other thing is, things like attention to detail. If you've got a button, when the user taps it, make them understand that they've tapped it. right? If something's appearing on the screen, bang, whoa, that's scary. But if it slides in or fades in or something, it's less scary. Just think about that. When you think that you've done a decent job of the UI, have another go, okay? Iteratively improve it, yes, all the rest of it, but at the end of the day, a mobile app is all about the UI. That's what it's for, okay? We do the heavy lifting on the server. The mobile app is just, with very, very few exceptions, it's just basically a portal to the cloud. Bingo, buzzword, yeah. All right, so, but seriously, right? I mean, I've got Photosynth, you know, Microsoft Research Labs photo stitching app. You know, you take a panorama, click, 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 and it automatically stitches it together for you. That's on my phone. That requires number crunching, right? Twitter doesn't. Facebook doesn't, right? All of the heavy lifting's done in the cloud. That's where it should be. You don't want to hose people's batteries by spinning their processors at 100%, especially not when, if your app runs their batteries down, they're just never going to open it. Once it's off their home screen, that's it, you're out. Right? So do the heavy lifting on the server, shun everything you possibly can away from the server, away from the client, which also means that your server-side code is reusable. Only the light UI stuff gets done on the phone, if you can at all avoid doing the heavy stuff. Async, don't make me wait. And again, don't make me wait. If I tap something, I want to see it, and if it doesn't do anything when I tap it, I think it's broken. All right. I am going to skip this because we're way short on time. So we'll flick through some simple stuff, some of the tools and languages that we've got to play with, and some of the components of the application itself that you're going to see either in Monotouch or in Xcode. So Objective-C, it's yuck. Right? It's based on C, kind of horribly messed around with by C++ and Smalltalk and other various variations on that theme. It's not a friendly place to be. It's as if the Next guys, Objective-C came from Next, right? It's as if the Next guys basically said, we want a language that's kind of like C and C++, but it's different so it looks different, not for any good technical reason. It's less readable, it's less conventional, it's really irritating. So, whole bunch of stuff that it doesn't do. Firstly, yes, readable is bad. It won't garbage collect, it doesn't JIT. You're missing a whole bunch of really cool stuff that we've just kind of gotten used to in .NET land. Right? You don't have the extension method, you don't have link, you don't have a whole bunch of stuff. We'll skip that, but we'll come back to it later. Xcode, well, you'll see it in a minute. Okay, so Xcode is used to write Objective-C applications, which compile to iOS. Monotouch, MonoDevelop, C# are the other combination. So MonoDevelop is the IDE. You'll see it in a minute. Monotouch is the cross-compiler. It takes your .NET assembly and compiles it to what runs on iOS. C# is obviously the language that you can write in it. My understanding is you can use Visual Basic. I'm going to leave that sentence there. All right, Siri, show me a demo. OK, so here's Xcode. It will eventually launch. All right, here we go. So we're going to go a very, very quick Hello World project. I'm going to use the wizard because we just don't have time otherwise. So we're going to go new project. It's going to be an iOS application, and it's going to be, where are we? A master detail app, which is a navigation, go forward, go backward thing that we've seen a whole bunch of times. Hello World Live. It's going to be for iPhone. No, I don't want unit tests. DDD Brisbane. Whoops. Scratchpad. Go. Great. iOS app, Hello World. And just to prove that there is nothing up my sleeve, I'm going to run it and hope like crazy that the emulator works. All right, good. So we've got an app. It's got a master view up here, and it's got a detail view. If we tap that, we're going to end up at the next page. Detail view content goes here. If we tap that, it's going to pop out the controller and send us back to the home page. Everyone's seen that before? Everyone's at least used an iPhone. If you haven't, borrow one from your grandma. All right, so what's under the hoodie? All right, we've got a bunch of header files and a bunch of implementation files. We won't go through them for now. Notably, we've also got these XIB files, which are your actual view definitions. Okay? So the concepts that we need to understand are the view controller, and the model. Everything's based around MVC. Here's how you define the V. The M in this case doesn't exist because we don't have a model, and the controller is the code behind it. So there's our header file for the detail view controller, and here's our implementation. Who can read that off the cuff? Oops. Can I scroll? Yeah, you can? All right, so right at the top of the screen, what's that method do?
It's instant vertical. It's instant that calls to the class and it's telling you receive a memory message. You've got a warning so you can clear on the cache frame.
Win. Well, if you bonus marks, sorry, I'm about to trip over. Incoming. Ah. Bonus marks, what's the first line of the method do?
Calls the parent inherited type.
Excellent. Calls effectively base.didReceive memory warning. I just picked that one at random, but that's basically what Objective-C looks like. Given our time constraints, that's as much of Objective-C as we're going to look at. Hooray. All right. Yes. I'm blaming it on time constraints, but really it's just because it's ugly, right? We all know this. All right, so same deal in MonoDevelop, which is also ugly. Right? It's not very good. I'm really sorry, guys, but it's just not. So we're going to go new solution. Oh, gee, this sounds familiar. We're going to go a master detail solution. You know what? I'm going to create it there because I can't easily browse. Actually, yes, I can. I'll just move stuff. Move, move, move. Him, scratchpad. Cool. Well, okay, and live. Want to touch. Make magic go now. Sorry?
They didn't really plan these boxes terribly well.
Yeah, what were we saying about UI design? Beautiful apps coming out of horrible places? Yeah. All right, so I guess basically to kick things off, I'm just going to launch that. Now you'll notice it actually launches the same iOS simulator as before with the same looking app. WannaTouch guys have basically just cloned that entire wizard. So we've still got a master and a detail view. All right. Hooray. Sorry, that's not an applause cue, by the way. Please don't. All right. Oh, and we're going to stop. All right. Now we're going to have a very, very quick look at what's in the master view controller, just so you can see what a table view data source looks like. So basically, we've got the give me that simulator. Run. All right. Sorry, what were we saying about debuggers not being so great? All right. So this is actually a table view. We've got a data source behind that. We've bound that table to a data source. The way we do that is, I know that, go away. Quit, go away. Go away. Wow. Yeah, I should. I really should get a Mac. It'd just work, wouldn't it? One of? So, were you in like Damien's talk a minute ago when he was talking about like 400 bugs that you've still got when you ship? No, well, yeah. The requirements were wrong. All right, so we're going to have a very, very quick look at our root view controller. If I can actually put it on this screen. If not, I'm going to hide it for later. You know what, this is horrible. All right, so the key is there's an event called finish launching. We hook up a window to it. We hook up our root view controller. That's all very nice. We make the window visible. We return true, and we're out of here. Okay. So that's basically our application's entry point. Okay. Now we need to know about that because we're going to set up our IOC container there, but we're not going to do it now. So I'm going to steal this back.
Is the binary size still several times larger for Mono?
It's noticeably larger, but not gigantically larger. Sorry, Wally, for asking a question. Incoming. Oh, 3 from 3 catches. We're doing all right. OK, so yeah, the binary size is actually not noticeably larger. Obviously, if you pull in an assembly, then the cross-compiler is not going to know that you're only using a couple of methods from that assembly. It's going to cross-compile the whole thing. But by and large, if you're using just system.core and system.data and a few other things, which all of your apps are going to use anyway, because they'll map to just the core data under the covers, there's really not that much there.
Last time I checked, the Mono binary was 1.5 megs and the Xcode one was 300K.
Yeah. What you'll find, though, is that that's basically an upfront cost for having a mono binary. But the incremental cost is effectively the same. So if you have an app that's twice the size, then your mono binary is only going to increase by the same amount as your Objective-C binary. So by and large, it's not really an issue. The other thing is the App Store 3G download limit's now 20 megabytes or something. So if you're shipping a 20 megabyte app, reconsider, unless you're TomTom. Well, yeah. No. Okay, development concepts. Everyone's heard of MVC. If not, I'm really sorry, but we're not going to have time to cover that today. Objective-C we've looked at, so we've got our header files and our implementation files, .h and .m. MonoTouch, we've still got the zib file, the XIB, which is an XML view definition, but we've got our standard C# code behind that instead. Yeah. All right, now I was going to demo an IB outlet, but I just won't because we don't have time. So an IB outlet is basically a way of getting a hook to a control. Okay, you create an IB outlet with Interface Builder, and then you say, I'm going to hook up this control over here to that outlet. So a controller just says, I have a text box called username. Okay, and the view just says, I've got a text box. Right. And you use Interface Builder to wire up the fact that the view has this text box, and the controller has something that looks like a text box that contains a username, so you wire them up. Okay, so the idea is that you keep the view agnostic from the model, from the controller as much as you can. This obviously helps for things like iPad apps. You can have the same controller, wire them up to similar but different IB outlets that do the same thing. Right? Actions, events. Okay, on touch button. There are lots and lots of different event types. So things like on touch up inside. Yes, I know, unfortunate naming, but that's what the event's called for pushing a button. All right. So this is what Interface Builder looks like. Right. Notably, the big black scary blob is where you hook up all of your outlets and your actions. Now, this is not what Interface Builder looks like in Xcode 4. It's changed. You actually drag controls into header files because that's really intuitive. Yeah, you pick up and drag a text box into the text, like into actually your code in the header file, and it magically creates stuff for you. So yeah, some cool stuff. We don't have time to demo all of these. I will save it till the end and then just walk you through a code base. So we've got threads, web services, database, location awareness, push notifications. You can use all of these pretty much as you know them. Okay. Threads are, I mean, it's the .NET thread pool still. Under the covers, they map to an NS thread, which is a next step thread. So the implementation details a bit different, but as far as we're concerned, you can just new up a thread and start it. You can add an existing work request to the thread pool. You basically use it as you're expecting to. The one thing is that, again, if your code in a background thread throws, your app's still going to crash. In the same way as IIS, in the same way as normal .NET apps, if you throw an exception, deal with it or your app's going to crash. Right? If you can't deal with the exception, don't catch it, but that's another issue. All right. That having been said, yes, I've spawned a thread, it's working, and then someone hits the home button, and it's not working anymore. All right. Your app gets suspended basically as soon as someone hits the home button. Okay. There's an event which we'll cover if we have time in the app delegate, which actually informs your app that you're about to be suspended. It's your job to save your state. If you don't save your state, you relaunch the app and you're back to the beginning. So don't do that, it irritates people.
Do you have a time limit on that, like you do on Windows Phone? Save state?
As a general rule, IIS will just nuke your app in about 10 seconds. If you don't respond to whatever it tells you in about 10 seconds, out of memory you go. So that's true on app startup as well. If you haven't hit the end of application did finish loading, 10 seconds after the users tap the button, out of memory. So. All right, so you can't leave apps running in the background. You can subscribe to notifications to get around this, location-based notifications, push notifications, and a few others. But by and large, once your app's gone, it's gone. Its state may or may not be persisted. It's not something that is Apple's job. That's yours. Right. The one catch with multi-threaded code, of course, is if you're dealing with UI components, make sure that you invoke any UI operations on the main thread, on the UI thread. Okay? UI components aren't allowed to be touched by anything that's not on the thread that created them. Okay? So invoke on main thread. So basically, user taps a button, we spawn a worker thread, do stuff, or we add a task to the excuse me, to the thread pool. It comes back and does a bunch of stuff asynchronously while our UI is responding and doing nice animaty, hey, you've pushed a button things. Right? And then it calls back to the main thread saying, hey, I'm done, here are the results. I want you to push this push this view controller onto the navigation stack and move to this page. Okay? So do your processing async. Web services we're not going to cover except to say that you can use them. .NET 2 web services work fine. Use MonoDevelop to create the proxy code. if you use Visual Studio to create the proxy code, you are in a world of pain. So use MonoDevelop. Just trust me on this one. All right. And yes, you can use WCF, but similar deal. Except, yeah, just say similar deal. We don't have time. Tech choices, databases. Core data is an ORM. Core data is not your friend. Okay. Core data is basically used for persisting an entire object graph. Right? So I create a bunch of objects in memory. I don't want to have to deal with relational tables or whatever. Insert, task, insert into tasks, task name, task description. All I want to say is, here's a task. Give me the task back. Thanks. Okay. That's the job of an ORM. Okay. Under the covers, Core Data uses the SQLite 3 engine. So it's SQL under the covers, just like anything else. Core Data constrains you to doing things in certain ways. It's not particularly friendly to .NET programmers. We're used to having a little bit more flexibility in terms of how we access our data. So I can't really recommend it. Your other options are system.data namespace, so you can hook up your standard SQL queries if you desperately want, or you can use, there are a bunch of other micro ORMs out there. The one that seems to be the best at the moment is SQLite.net. It's open source, have a play with it. It's in one code file, so you can just copy it into your project. You don't need to include an assembly or anything. iOS, in general, is not good at SQL. Try not to use it. Right. Location services, we've got a whole bunch of stuff that we can play with, but not today. Sorry. Except to say that you've got different granularities, and that's actually important, because if you ask it for a really accurate location, you'll hose the user's battery, so don't. Okay. Ask it for just cell tower notifications unless you're actually doing navigation services. Okay. All right. Push notifications, use Urban Airship. Again, we'll skip that. Bogus stuff, things that it doesn't do. We've covered that it doesn't do dynamic compilation. That means system.reflection.emit, no. Right? What does that mean for generics? Got to be pre-compiled. All right. Yeah. Oh, sorry. So generics work, but they work by static analysis. What that basically means is that the ahead of time compiler goes and has a look and says, what generics are you using? I have to create a type name backtick1, whatever, for this particular type. And if I can figure out which ones you're going to use, then I'll actually create a concrete type for that for you and stick it in the assembly. And if I can't figure it out, then you can't have it and it won't run. Okay. So you have to help it a little bit. Oops. So obviously that means no JIT, just no code emission, no fun. So let's have a very, very quick look at Reflection Generics IOC. We're not going to get to cover IOC today. We started late, it's just not going to happen. So unless somebody desperately, desperately wants to see IOC in an iPhone app, in which case have a chat to me after, but we're just not going to get to it. Reflection, we've got full access to everything in the system.reflection namespace except system reflection emit, for obvious reasons. So we do have some questions up here. What should still work in terms of generics, right? We've got our ahead of time compiler, right? It can statically analyze everything we're going to use as a generic if we use a concrete type. What about if we code to an interface? Are we in trouble? If I take a dependency on ifoo and I get given a concrete foo, the ahead of time compiler doesn't actually know that it needs to have compiled a foo of type T for me. It could have been another foo of type T. It could have been some generic implementation that it doesn't know about, so it won't have pre-compiled it. Okay. So bear that one in mind. IOC, we skip. All right, to the codes. Yes? To the codes? To the codes. All right, he gets a lolly just for being enthusiastic. All right. So my dev environment, this is the last slide, by the way. My dev environment is a couple of laptops. That's because this one's actually running parallels with the Windows 8. Don't try to develop on Windows 8 yet. I'm using Dropbox to sync between the two, largely because I need MonoDevelop to compile the code, but I desperately want Visual Studio to edit it in. Okay?
That is true.
I'm sorry, I cannot live without ReSharper. It's just, it's a horrible place. But even with just Visual Studio, it's still orders of magnitude better than MonoDevelop. And I'm really sorry to the MonoDevelop guys, but it's true. So you're probably, given that we've got about 5 minutes left, you can have 2 code samples. What sorts of topics would you like to have a look at? How have I done this? How would you approach that? I've got a production code base that we can play with, where I've got working examples of pretty much anything you'd want to see in that sort of time frame. So there's a lolly for someone to suggest.
Offline data.
Offline data. Win. OK, cardinal rule number 1. Right? Cache what you can, prefetch what you can. Don't fetch things and wait unless you absolutely have to. If you can prefetch it, do it. OK, so offline data, we've got a repository pattern that we'll skip except to say that there is one. There's a SQLite repository, which we can shrink out of this guy. He'll take a SQLite connection factory. So basically, you take a dependency on iRepository of T, which you write. You take a dependency on SQL connection factory. He takes a SQLite connection. So the bit that you're actually caring about is using the SQLite class, which is from the SQLite.NET library that we're looking at. We're going to use a SQLite database. Can everyone see that? Do I need to make the font bigger? Crank it. How's that? All right, cool. So we're going to create a database file name like that. We're going to use system environment or special folders because you can and they're there, and you should. Create a new SQLite connection. Awesome ORM. Create tables for all of these classes. Thank you. Done. So basically, you ask for a repository of whatever type. You see, this is something that I'm writing for the Redify guys that they haven't seen yet. So no sticky beaking. But so something like, let's say a consultant themselves. A consultant. All right. Consultant has a first name, a last name, a position title, and a bunch of other stuff. All right. So we're going to create a table for the consultant that maps all of that stuff. It'll also map all of the consultant's relations, but by and large, don't use those. Don't actually use the traversal functions of your ORM because SQLite's just not up to the job. So take a dependency on one individual table and do your foreign key lookups yourself, by and large. OK. The other thing I'll say with fetching data in general is you have to lock. It's single-threaded. It's a database file. It's one file on disk. One thread should access that file at once. Otherwise, it's going to go horribly wrong. So the end class we end up with is a table query, which has a connection object. Under the covers, it actually writes a whole bunch of SQL. Where are we? So basically, we're building a SQL expression here. Now, this is the ORM code. You can nick this from, I think it's on GitHub, so you don't have to write it. But basically, what we've got is the ORM layer is actually just writing a SQL query and passing it to the SQLite engine. So at the end of the day, we've got a whole bunch, where are we? A whole bunch of SQLite stuff that looks remarkably like this. We've got a whole bunch of extern DLL imports. And here we are. So we're hooking straight back into SQLite 3 that's supported by iOS. Okay. SQLite is flaky. Right? So when you're using it, be gentle. I hate to say this, but put a sleep in after you've done an update, because if you do 2 updates in a row, it falls in a heap. Yeah, only for 100 milliseconds, right? But seriously, be gentle on your ORM, because the data layer underneath it, it's not very good. OK, we have time for possibly one more quick poke around. How would I do something? So who's got a lot? Angry Birds. Angry Birds? OK, location services. There you go. And I'm going to send a lolly to Damien. Just, whoa. Whoa.
It's just like Angry Birds.
Thank you. Whoa, the ceiling's different height. I got to notice it. OK, location services. All right. Now, let's grab this. OK, so location services. Bear in mind that we're using IOC to actually pick up all of these dependencies. So don't worry too much about the plumbing. But what we want to do is we want to create an instance of the CL location manager. And we want to tell it, I'd like you to tell me when any of these things happen. All right? So you don't want to be polling for location. Right? The iPhone finds its location from a whole bunch of different ways. You don't care how it's done it. Right? When you ask it, it will give you a GPS location. It will give you latitude, longitude, regardless of how it's figured it out. It'll also give you an error margin, so pay attention to that if you care. Reason being, things like it'll use Wi-Fi. If the Google Street View van has been around and mapped your Wi-Fi access point, you'll find that it can actually locate you just from your SSID. Okay? It'll also use your cell tower. Same deal, right? The Google Street View van and a whole bunch of others have mapped cell tower locations to GPS coordinates. So it will use those, and it will also, if you ask it to, spin up the GPS receiver in the phone. So you can ask it for how much detail you want. In this case, I'm telling it to start monitoring significant location changes, which means when I've moved between cell towers, not please spin up the GPS. If you do that, you will hose the user's battery. So spin it up, get the location as accurately as you need it, turn it off again. Okay? We get a whole bunch of events. Thank you very much. We get the old location and a new location. If we don't have a new location, we just bail. And basically, a location comes out as a coordinate. It's got altitude, latitude, longitude, horizontal accuracy, and vertical accuracy. I've never found a use for vertical accuracy yet, but one day we might. Okay. So, sorry? Well, if the Google Street View van went up and over the building and then back down again, then maybe it would. No, actually, we've got some in the room.
So in general, how do you actually interact with Apple iOS?
So as a general rule, anything that exists in the next step namespace will be prefixed with an NS whatever in Objective-C land, and there's a rough mapping of those objects, of those classes to monotouch classes. So monotouch.dll has basically shims and wrappers around everything that that Objective-C will have for you. So by and large, if the Docker says use NS this or CL that, then odds are there's going to be a monotouch class that looks very similar. Okay, guys, we are going to have to call it there. If you have any last questions, feel free to grab me. I'll be around for a little bit after the lock note. Otherwise, thank you very much. Enjoy your lollies.